Welcome to BBS Pragati channel. In this session, let's have a look at the circuit design of broadband MMIC SPST switch using gallium arsenide MESFET. So what we are doing, we are using gallium arsenide MESFET as a passive device. So it acts, in last few sessions we have seen that it acts like a resistor in on state and as a capacitor in off state. So to achieve low insertion loss and high isolation, the effect of the source to drain capacitor has to be considered. So in the series mode, what is happening? The series FET improves isolation at low frequencies, whereas the shunt FET improves isolation at high frequency. So if you use both, you can have a benefit of better isolation at low frequencies, which is improved by series FET, better isolation at high frequencies, which is improved by shunt FET. How? So in the series mode, what happens? This is when this is off, it provides better isolation, right? So what is the reactance? 1 by 2 pi f CDS. So as f increases, the reactance starts reducing, hence isolation is poor, whereas at low frequencies 1 by 2 pi f CDS, as f is low, the reactance is high, so it acts like a open. Okay, so at low frequencies this is providing better isolation. At high frequencies, since this reactance becomes less, because 1 by 2 pi, what is reactance? It is 1 by 2 pi f CDS. As f is high, reactance is low, so whatever signal is there, it is bypassed to ground. Okay, so that way it provides isolation at high frequencies. And the shunt FET CDS is used to form an artificial 50 ohm transmission line with the addition of a series inductor. So this configuration not only improves insertion loss but also ensures good return loss over full bandwidth. The series FET improves isolation at low frequencies, which we have seen, okay, and this improves isolation at high frequencies, that also we have seen. Furthermore, what we are doing, we are adding a 50 ohm resistor connected in parallel with each series MESFET. What happens? This minimizes the parallel capacitance in the isolation state of switch by allowing series FET to be biased below their pinch off. The 50 ohm resistor in parallel with series FET, this allows us to attain good return loss even in the high isolation state of the switch. And this 50 ohm resistor eliminates the otherwise necessary adjustment of control voltage to bring series FET resistance to 50 ohms. And you don't need DC blocking capacitors, because here it is used as a, this MESFET is used as a passive device. The resistor eliminates the otherwise necessary adjustment of control voltage to bring series FET resistance to 50 ohms. And what we are doing? The biasing is done through 5 kilo ohm resistor. Thus, it improves the performance of SPST switch at low frequencies, and also it reduces chip size. So, and after this design is simulated and optimized using advanced design system. And we will discuss about the results in the next session. Thank you. Thanks a lot, and I wish you all the best.